All right, hi everyone. Today we have Codeforces around 1111, Division 2. Array A. Perform the following operation in the times. Take I and assign negative. Um, Make the sum of elements of A equal to 0. No. This is yes. No. This is no. This is no. And this is yes. Okay, right. So basically, you can go 2 to negative 2 or negative 2 to 2. So if you calculate the sum, this is 1 and this is negative 4. So this would work. It's problem. N, K, and M. We have an array A of length n consisting of positive integers. Good if the minimum length of a non-empty subarray of A whose sum is divisible by M equals K. So it's good if there exist integers that it's divisible by M. Um, so basically, okay, so and then if it's less than M, it's not divisible by M. Okay. Find a good array or determine that none exists. First of all, right, if 2 times M is less than or equal to N, the output is null. 535. You can just output 1, 1, and then, um, 3, like 1, 1, 3, let's see, 1, 1, 3, um, and you can't do 1 over here, right, because I have to mod. Can't do 1, so you can do 2. Uh, and you can do 2, so you can do 3, right? This should work. 1, 3, 2. because it's always unique. There's always a value that satisfies it. So, yeah, but if it was 5, 3, 2, and we have 1, 1, and then we need array of length 3. You're right. So change this 0, 0. We need ones. So 1, 1, and it doesn't work over here. All right. So M also has to be less than K. Right? If this was 3, and we can do 1, 1, 1, and then 2, whatever one the 1 1 here. So say 7, 3, 4. 1, 1, 1, 1, 1, 2. And then you can't have a 1 here, so you can have a 2 here. You can't have a 4, 1. You can't have a 3. You can choose a 1. Right? And then you can go 2 again. Now 1, 2, 1, 2 like this. So this is okay, 1, 1, 2. I have a 1, 1, 2 over here. Let's see. 2, 2, 2, right? You always have a 1 and 2 2s, so that's okay. Let's see. If you have 9, 4, 9, 4, 4. So if M is less than or equal to K, if M is less than or equal to K, I'll put no. If M is less than K, right? I think equals short. You have 1, 1, 1, 1, 1, 1. Yeah, and then so you have a 2 here. 2, 2, 2, 2, and then 1, 2, 2, 2, 2, and then 1. So basically you have 4 2s at any spot. Right. Okay. Let's change this to 3. 1, 1, 3, 3. So you have a 1, 1, 3, and 11, 3, 6. 1, 1, 4. Right, so this is K minus 1 over here, and then just the rest. 1, 1, 1, 3. And then you can't put a 3 there anymore. Okay, yeah, but you can put 5s, right? So you put 3 5s, and then you put a 3. Oh, and you put a 1. Um, So basically you cycle fives and ones. M minus ones and ones. Okay. So you have k minus one over here, right? K minus one. So right now you have k minus one plus one. So you have k over here. Right, so you can do n minus equal to k. Answer. Um, equals k and it's divisible by m. Okay, if we start off all ones, um, then right, first of all, if k is equals to m, this would work. Okay. But if k is greater than m, right? So if k is say m plus one, so we have if k is m minus one, we have 3, 4. Basically you need a length of 3 and it's equal to 4. So you can just add a 2, add a 2, add a 2 for every third one. Right, because for any 3, you always have a 2 and a 1, and then, okay. Okay, so 1, if k is less than or equal to k minus 1. Less than or equal to k, with less than k minus 1. And otherwise, we just output m minus k plus 1. Correct. Alright, so this is passing. Okay. Inversion of a subsequence. Int n vector int an, bn. Mm. So choose k indices and the sum is odd. Set 1 minus aij. Infer all elements of the chosen subsequence. Okay. Uh, Transform A into B. So choose k elements such as the sum is odd. Uh, okay, so you can use one operation. This sum, right? So you can just first do these, and then you do this one. Okay. And for this, the difference is just these two, which sum is 0. Okay. Else if s mod 2 is equal to 1, else put 2. Is 0 found 2. Um, Answer precast 2. I mean, right, if I would assume if you have 2 over here and then 1 to 0. Okay, right, if mod 2 equals 1, you can just infer all of them. Otherwise, output 2 because you can split it into 2 parts. One operation, 2 operations. Right, so when we do it, it's either 1 and 0 or something 0 and 1. Right, so those are the ones that need changing. Is it always when CNT is greater than 0 and SS equals 0 is -1? Let's see. So if you have 3, right, let's say 1, 0, 0, okay? You have 0, 1, 1, okay, 1, 1, 1, 1, 1. Um, Thinking there might be other ways to get 3, 1, 1, 1, 1, 0, 0, 2. You're right. So in this case, it's actually none. What about similar case? Let's say 1, 0, 0, 1, 1, 1, 1. 1, 0, 1, 1. So we use this 1. Wait, but in this one, it's actually valid, right? We're gonna use 1 over here and then these two. So it becomes 1, 1, 1, 1. And then we use this one with this one and we make it valid. Okay. Um, yeah. So just fix this part. So what do you do here? CNT greater than 0 and S is equal to 0. So basically a bunch of 0 ones. If C1 is greater than 0, and C00 is greater than 0, you can output 2. Otherwise, we output -1, right? Let's see. All right, we get 2 here. But 4, 1, 1, 0, 0, 1, 1, 1, 1. Here is -1. Okay. Because after we invert it, some 1 must become 0, right? So, okay, so 5, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay, yeah, this seems okay. 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 Q is 0. So with queries, right? Okay, so int n q 0 base indexing is used. Got two wrong answers. Um, choosing indices such that XOR is less than or equal to K. Applies to indices I and J, not to the elements B, I, and Bj. Swap the elements B, I, and Bj. Okay. The smallest non-negative integer K, so that array B can be K sorted. Um, so no queries. Just ask if you can make it possible so that it becomes 0. Minimum K. So see, there's only have one. One needs to go to one of these positions. One needs to go here, right, with two. Yeah, XOR, right? XOR. This is binary search. Probably not, right? And it's up to 10 to the 6. Could be though. Could be. Okay, so basically there's some indices that we can um get, right? So let's see, 6. I'm gonna write first really quick. Okay, for int 0, j plus n, j plus plus. So now we're equal to right 4. Okay, so zeros, right? And then ones, 2, 3, 5, 2, 3, and then 4, go to 5. Basically, I think just move 1 Move it as much left as you possibly can. So we have some uh values and then we have some targets, right? So here, 1, 2, 3, 4, 5, 6. Okay, so 5 wants to get here, 2 wants to get here, and 1 wants to get here. Okay, no. So you have some cycles. Mm, 0, 1, 3, 0 and 4, 1, 4, 5. They were all unique values and it would be easy. So X or the indices is less than or equal to K, then you can swap them. Utility tree. Oh, so construct a tree of n vertices at distance. That's equal to K, or determine that no such tree exists. This one's interesting. Okay. Um, sum of all distances between adjacent nodes is equal to k. Node 1 to node 4. Node 4 to node 3. Node 3 to node 2 and node 5. For cells of S. Two, two, three, two. So 1, 2, 3, 4, 5. Three, 3, and 4, 3. Right, so this one and these four are definite ones. So you can add them to everything basically. Um, so times 32. 1, 2, 3, 4, 5. Then you have 1, 2, 3. These two are together and this one's by himself. Um, so these two, you can choose any of them. So 2 squared is 4. And this one, 6. 4 plus, no, 4 plus 1. So 3 plus 1 is 4. So you have 5, and then you have 2, and then you have 1. So I think I'll focus on this problem. Basically, right, you can swap some of them. 1, 2, 5. There's these 3 indices. One zero, 101, and 1. 11, 3, 4, and 7. AI is not equal to TMPI. E dot pushback I. Right, so those are the indices that don't work. So basically K is at most N, right? Yeah. Um, K is at most N. Because you have zero. Zero can go right anything zero. Okay. So every K indices 0, 1, 2, all the way to K are okay. So they can swap with each other. One is a 1, 0, 0, 0, 0, 0. So you missed out on one. For any two indices, you only have to look at their XOR. If K is okay, think, right? So if you have 0, you have 1, 1, 0. Okay, it's basically you can subtract 2 from that, or you can subtract 1. You can't subtract 1. You can subtract 2. So basically, that's what it means, right? Yeah. 1, 1, 1. You can get subtract 1. 0, 1, and 1, 0, 1. So 0, 1, 2, 3, 4, 5, 7, 8. Okay, so group of 4. Groups of 4. So k equals 1 results in groups of 2. K equals 2 results in groups of 4. Right, k equals 3 results in groups of 8 and so on. Okay, so I think maybe solved it. Um, so k equals 3 basically does nothing. Okay, so L is k times 2. Um, so basically you can split into groups of k. J is I, j is smaller than min n, I plus 2 times k, k plus plus, square dot push back, aj. Sort here for x square, e dot push back x. B is equal to TMP, C out k, return. 014. This might get time limit though. N is 1E6. Oh, why is there a bunch of zeros? That seems okay. It's time limit, 2 seconds. I can always fix it. Oh, we got to remove this. I think this will time out though. But nice. Yeah. Wait. I think I can solve D2 also. Like just using this method. AI to pushback I. For every AI, so for entire 0, I smaller than n, I plus plus. Okay, MP3 MPAI back is equal to I. While Q minus minus, IX. It's gonna test out if this is correct. No. Uh, AI TMP. So this is correct. Should I submit to D1 again? Don't think so. Okay. I am K, so AI turns into K. AI turns into X. So if AI turns into X, basically, um, some things get shifted, right? Either to the left or to the right. Worries about the max max index difference from the current array to the sorted array. Given an array A and the sorted array is A, um, find the maximum distance between a value, find the maximum difference of the index between a value in both arrays for every value in A. So let's draw this out. For you can let's output S, okay? Zero 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 1 4 0 and a bunch of ones and then a 4 and then all zeros. Okay. So when we changed 5 to 2, everything in between this 2 and 5 got +1, right? So 3 and 4 they got +1. And then when we changed 1 to 5, everything in between it got -1. So everything in between from 2 to 3 and 4 they all got -1. Okay. Um Segment tree, right? Okay. Range add plus range min. Yeah. This is one of my templates, so it should be okay. I probably can use it. Range add plus range min. Okay. for values of s, so uh array. Just write tree. Seg.code. A 0 0 to n. 3. No, we can change this to 8. Where is it? Right here. Control F long. Just change everything to 8. Let me get this. Oh, we need n minus 1. Oh, it should be range max, right? I don't have range max in here, but I'll just change this to max. Or 1 0. Okay. Um, and then over here, right? AI turns into X. So we can basically find what index X is um in this new array, right? So it was at uh it was at index, let's see. It was at 3i. MGAI back. Oh, vector 8 was at. So it was at I. Now it turns into X. So we gotta find which index it is at now. So basically, we can use a tree. We can use an index set for this. Yeah, it's equal to X. Okay, so we can update this at the very end. Um, Q dot erase AI and I. Uh, new index. Q dot order of key. X and just do N. X and I. Alright, so this is a new index. In re index. Having MP. Why do we have MP? We don't need this MP. AI and I. And our index is T dot order of key, AI and I. And then just was at I is equal to this index now. Here equals ABS I minus IDX. We have our seg tree, right? Yeah, that should be correct. Unless it's something about the seg tree that's wrong. Okay. We don't even need this was that, I think. Key dot order key AI and I. This is the pre-index, and then we have our new index. Okay. So right, if pre-index, that's right, PIDX. So we have PIDX and I and new index. Okay, so for everything from PIDX to NIDX, we all give it plus one, right? Some amount. Pre-index, new index. Okay, let's put in some cases, right? If pre-index is less than I, and if pre-index is greater than I, Okay, so if it pre-index is over here, so you move I to pre-index. Now you're moving I over here, so some things will change. You apply and you have combine. Yes, okay. Think from everything from pre-index to new index, you always add, right? So if pre-index less than new index, seg update 0, 0, and -1. L will be pre-index, and then new index, and you add 1 to this. Um, right, else seg update 0, 0, and -1. New index, pre-index, -1. Also right, seg update. Let's see. Oh, new index, new index. What do you add to here? Right? You add index minus I. You add so it becomes new index minus I, right? Yeah, it becomes new index minus I, and then you minus AI. You just got to add to it. 4, 4, 12. Wait, actually, it should start from 1, right? Yeah. Okay. So 1, 3, 4. So we get 4. And then once we get to here, 5 updated from there to here. Okay. 5 got updated. 5 was supposed to go to 1. Now it's supposed to go here. So pre and new. Pre-index greater than new index. Uh, yeah, pre-index. Wait, pre-index is greater than new index. Yes. So from key idx new idx 1. One 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 five. One was gonna go here. What? Okay. (1,300 -40). X new index. Okay. Alright, that's it. I really could have solved the last problem though. Um, I'm not sure where my secretary solution's wrong, but I probably should have been able to solve the last problem. So I guess I will upsolve it. Meanwhile, I will go over my solutions. So basically for problem one, um, it's this one, right? Yeah. Uh, basically, um, to change any values, it must be 1 1 to -1 -1, or -1 -1 to 1 1. So it can come from 2 to -2 or -2 to 2. So basically, the sum has to be modulus 4. It must be 0 because we can increase or decrease it by 4 any number of times. So as long as the modulo 4 is 0, we can output yes. Otherwise, the answer is no. So I just find the I just take the mod, just find the sum. I plus 2000 to make it positive integer, and I just take the mod. Uh, next problem B. So okay, so basically in this problem, we do something like this, right? We do uh we make a bunch of ones, and then we do m minus k plus 1, and then we do a bunch of ones again, and then we do m minus k plus 1 again. So right, how do you do this? Right, for example, we have k is 3 and this is 6. So basically first we do two ones, right? And then we add a 4 on this um, to make it equal to 6. Okay, and after this we do two ones again and we add another 4. So basically it cycles 114, 114, 114, and so on. The reason this works is because um, for any three consecutive numbers, every k, there's always a 4 and two ones. So basically, every consecutive k is always equal to 6, and everything that's less than k, that's less than these k, right? So basically, you either lose a 1 or you lose a 4, which will not be good for you. Because the sum is equal to this m. So if you lose something, you can't ever get to m, right? If you use -1 from m, you'll never be able to get to m again. So basically, if you just do the cycle, it would work. So that's basically what I did over here, right? I use a counter. Um, so I output 1k minus 1 times, and I output m minus k plus 1 the last time, and then curve plus plus and minus minus. Right? And if m is less than k, the answer is no, right? Because if m is less than k, you can't even do a bunch of ones to make it equal. Okay. So next problem C. Okay. So first, um, I'll just say some cases really quick. So basically, first of all, right, um, ones can only go to zeros. If you have a one on the top, you can change it to a zero, and you can change any number of other things, right? Um, so first of all, you find a number that the amount that are different for A and B, right? For example, over here, the CNT will be 2. So if CNT equals 0, you can output 0. Otherwise, if CNT is greater than 0, right, and S is equal to 0, so basically, S is the sum of the AI, such that it's not equal. If S is equal to 0, then I'll go through this later, but otherwise, if S is odd, then we can just choose all of them and we'll output 1. Or we can just choose, we can just split it into 2, right? For example, because S is equal to 2, we can split into 1 and 1. And then, so we need two operations over here. So if CNT is greater than 0 and S is equal to 0, there's actually a way for it to be okay, right? Such like this. Because from this you can change it to 1 0 1 1 1 1 1 0, and then you can change it to 1 1 1 0 1 1 1 0. right? You in the first operation you use this and you choose these. You in the second operation you choose this and then you use this. So basically for this case to be valid means you must have at least one on the top, and then you must have at least one of these zero zeros. So that's basically what I did, right? If there's at least one, and if it's at least a zero zero, then we can output two. There's always two operations. Otherwise, it's always not possible. For D1, D1 is basically I found this observation where if you have some distance, right? For example, so for every power k, that's a power of two. For example, k is one, and we can output any lengths. For example, let's see, if the array, right? One, two, three, four, five. These are the indices of the array, right? So if k is equal to 1, then 0, 1 are connected, 2, 3 are connected, 4, 5, 6, 7, 8, 9, and so on, right? If k is equal to 2, then 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 connected. And if k is equal to 3, then we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And if k is equal to 4, then they're all connected. So basically what you see is that the length of k, if k is 1 or k is 4, k is 4, 8. If k is a power of 2, then the length will be just 2 times k that are connected. So it form blocks of 2 times k. So that's basically what we can do here, right? We iterate over all the powers of k, that's all k that are powers of 2, and we calculate Um, so basically we calculate the different blocks and then we can sort them, right? Because they can all be changed by themselves. They're a single block. We put them in this B. If this B is equal to the sorted array A, we can just output our K and we're good, right? Otherwise we just keep going and keep going. Okay. Yeah, so that's A, B, C, D. B1 I can probably solve, but there's probably some bug. I didn't think through it correctly. So yeah. Alright, so this is the contest. Um I'll be doing the Ripple Vibe contest tomorrow, so I'll post it like tomorrow. So yeah, bye.